Trauma-Informed Care in Nursing Homes video series. Video 2, Neurobiology and the Flipped Lid. Welcome to our Trauma-Informed Care video series for nursing home staff. Today we will be talking about neurobiology and the effects of trauma on the brain. One of the ways trauma has a significant impact on us is related to how it affects our brain processing. Specifically, how it affects our perception, attention, and memory. If you think about the idea that humans are oriented towards survival, trauma creates a situation that puts our mind and body in a state of survival. You may have heard this described as fight, flight, freeze, or fawn. Our brain processes information from our outside world in the form of sensations, sights, sounds, smells, and textures. An area of the brain called the thalamus is one of the first areas that receives the sensory information and tries to make sense of it. The thalamus is known as a relay station because it will send this information to other areas of the brain for further processing. For example, when the sensory information is signaling threat, the thalamus involves the amygdala, which is like a smoke detector that is on alert for threat and danger. The amygdala gets input from other areas of the brain that can make sense of this potential danger. For example, the hippocampus, which is the area involved in long-term memory, can offer context. Imagine you're walking around a corner and you see something laying in the middle of the hall that looks like a snake. Your amygdala freaks out, thinking danger, danger. But your hippocampus could offer context, such as the fact that you know your child has a stuffed snake and was playing with it earlier. Context can be very helpful for an alarmed amygdala. It's also helpful that the amygdala can get input from the prefrontal cortex. This is the area of the brain that offers regulation, impulse control, decision-making, and planning. So imagine with our snake example, the prefrontal cortex could calm the amygdala down in order to think through what to do next. One of the options may be to activate a threat response by initiating our sympathetic nervous system. This is like an all-hands-on-deck kind of alert. Through messages that get sent from the brain to the body, we get ready to react. Remember when I said our response to threat and danger is to fight, flight, freeze, or fawn? This is how that happens. A brain area called the hypothalamus sends a chemical message that makes its way through to a part of the body called the adrenal cortex. This area releases adrenaline to help us run or fight. It also releases cortisol, which makes us more alert and engaged so we can focus our attention on the present moment. When you're in survival mode, your focus becomes very narrow, as it should. You're looking at what's right in front of you. What's happening in the present moment, and how do I survive this right now? It wouldn't be helpful if you were thinking about what to make for dinner. Instead, your brain becomes very focused on the details of the threatening event. What I've just described is often called bottom-up processing, when the information comes up through your brainstem in the form of sensory details. Because you haven't made meaning of it yet, the details are like fragments as they come in. There isn't context to help make sense of these details yet, and there's an absence of time and space. In addition, adrenaline has helped crystallize the important information and form sharp memories related to the dangerous situation. Because we're talking about trauma's impact on memory, it's also important to note that non-essential brain processing takes a bit of a back seat during a threat response. So your brain may seem slower, fuzzier, and less able to remember other non-threatening information. In other words, it's not advantageous in the face of danger to think about what's for dinner, and furthermore, you won't be able to remember any of these thoughts. The brains of people who have experienced a lot of trauma and who've been in survival mode often are actually more sensitive to sensory information. Sensory information is what is going to help you spot danger or safety, so it makes sense to pay close attention to it. However, these brains can get so sensitive that they react even in the absence of real danger. You might notice that people with trauma histories startle more easily or are more sensitive to loud noises. Smells may be stronger to them, and sights may be brighter. If incoming sensory information is similar to the details of a dangerous situation, it will trigger the same threat response. Your brain might not be able to tell the difference. As I mentioned, what we were just talking about is called bottom-up processing. It's also helpful to understand top-down processing and how that may help in terms of threat detection. Top-down processing is where we add the context, the experience, and the memory that helps us make sense of the situation. In the earlier example of the snake in the hallway, top-down processing is what helps you remember that your child dropped their toy snake. Context can be really helpful, but what we have also noticed with trauma survivors is that traumatic experiences can create the tendency to perceive life in a certain way. In psychology, this is called perceptual expectancy, or rather, the expectation that things will happen in a certain way because they've always happened that way. What we need to remember with trauma survivors is that this has been an adaptive strategy in their life. When you know that there might be danger around this corner, then every time you go around that corner, you need to expect danger or you will be at a disadvantage. This strategy is survival-oriented and it's adaptive. It can be a problem when this becomes a pattern that is used all the time and people don't allow for the other times when it's not like that. Therefore, our work is to show these individuals that it's not always going to be this way. Dangerous situations have to keep repeating themselves. The other thing I want to point out is that staff can also have their own sense of perceptual expectancy with residents or staff members. For example, care plans that follow people, thus leading us to develop our own sort of perceptual expectancy. We expect that what happened in the past is always going to continue to happen, which can make it difficult for us to see a different way forward or to allow for a different opportunity. In summary, trauma can bias our perceptions through both perceptual expectancy and heightened awareness of sensory information. It can focus our attention so narrowly that we don't pay any attention to other things happening around us. It can impact the memories we form, favoring those that are related to the dangerous situation. Other memories may not be formed at all, and our brain may process differently, quickly as it relates to our fight or flight system and getting away from danger, but slowly as we make sense of anything else. As care providers, we aren't aware of what's happening in another person's brain. All we get to see is the behavior they exhibit. Often we take this behavior at face value, and we don't ask ourselves what else could be going on, especially as it relates to brain functions we just talked about. An important developmental opportunity is to be curious about the behaviors we see. So the next time a resident presents with a difficult behavior, rather than just thinking that person is difficult, consider what else could be going on. If we consider how trauma affects perception, attention, memory, and brain processing, then we might have a better understanding of the behaviors we encounter.